Hi, my name is Johanna Young, and I wanted to talk to you today about teaching addition and subtraction within the numbers 1 through 20 in a multisensory way using the Concrete-pictorial-abstract approach. The pre-skills a student will need for this is to know their number bonds through 10, whether they learn those with dice dot patterns, 10-frame patterns, 10 frames Cuisenaire rods, any or all of those methods. So if they know their dot patterns through 10, they can move on to this skill. This video is for parents of dyslexic and dyscalculic children who struggle with math, parents of students I'm tutoring, so that the parents can become familiar with the methods their child's learning so they can then apply that in everyday life and their homework. And any teachers, tutors, or parents of students who are struggling with math, and multisensory math is really for all students, even gifted students. It helps everyone with math. Okay, so this is my general sequence of instruction I go through with students in the K through 5 curriculum. Today I'm going to be talking about calculation within 1 through 20, so that's where we are. And it's really part of the mental math teachings from the first 3 levels here. So before we even get to the place value system and column addition and subtraction, or formal written addition and subtraction, we are giving kids these visual methods, visual and tactile methods for doing mental math. And it's kind of the basis of multisensory math, and it's certainly the basis of Singapore math, which is one of the original multisensory programs. A little bit about me. I'm an online tutor for dyslexia and dyscalculia. I'm a certified Barton tutor, that's for reading and spelling. Currently training to become a certified EBLI tutor. And I also tutor multisensory math online. And the reason I'm here is because I'm a parent and spouse to 2 dyslexic kids, and also to a spouse who's dyslexic. So I've had to learn a lot about math, reading and spelling, and neurodivergence. I tutor completely online. Here's my cluttery desk. I love math. I have a master's degree in mechanical engineering, so I've always loved math. And now that I've learned multisensory math and I teach multisensory math, I can say I love math even more, and I'm even better at it. Even though I was considered good at math, multisensory math has really improved my math skills as an adult. Lots of manipulatives. If you're doing multisensory math, your desk is going to look kind of like this. You're going to have all the 10 frame or the 10 blocks and the place value coins, Cuisenaire rods, dominoes, play money, Singapore math books. I love math books from the 70s and 80s when teachers and were still learning to use these great tools, Cuisenaire rods and tens blocks with kids. Yeah, so any of those old books and lots of Cuisenaire rods. Okay, here's everything I teach in this video is coming from these books, the Dyscalculia Toolkit and Exploring Numbers Through Cuisenaire Rods, which is an ebook. Those are both by Ronnie Bird. She's in the UK. She's a special education math teacher, specifically for dyslexia and dyscalculia. And the Dyscalculia Solution book, also by educators in the UK, Jane Emerson and Patricia Babty. And then Singapore Math, of course. Okay. So first, before we get into the problems, I'm going to talk a little bit about math anxiety. Because at this point, when I'm teaching students beyond the numbers 10 or even before, a lot of the students who come to me are already in 5th, 6th, or older grades, and they have not gotten the help they needed for multisensory math, and they're kind of in a crisis mode. And they've, if you can't understand addition and subtraction because you haven't been taught in a multisensory way, you're not going to be able to understand multiplication and division, and it's going to lead to a lot of self-esteem issues and math resistance, because it's to resist learning more math is really self-protection, because it feels like they're going to experience bodily harm whenever they're presented with these problems that they just don't have the support to solve. So the first thing is recognizing anxiety in a student and then working through that first, and while you do the math. So we really have to be patient and provide lots of hands-on, lots of examples, and lots of successful experiences. If you want to learn more about math anxiety, Steve Chin, who's also a UK educator, great. He's done really great work. He has books out. On his website, you can find all kinds of information about math anxiety, and especially this part here, what do students think? It's so important to ask your students why they're having trouble with a concept, or what's confusing, or what gives them anxiety, so you can work with them. And then also on the Made for Math website, they have a Learn page and lots of great resources there. So there's an interview there with Adrienne and her guest, an educational therapist, talking about math anxiety. Very common, even for people who are considered good at math. If you have to do math on the spot or you're stuck on a problem, I think we've all experienced math anxiety before, but for some students, it's really paralyzing. So got to work through that. Okay, so why am I bringing up all this anxiety stuff and not just talking about numbers first? Well, it's because, we have our 10 fingers. So numbers within 10, students always know they can go back to their fingers. They can realize. So they're going to count on their fingers if they need to. Of course, we're going to teach them other ways, but they really haven't learned to have anxiety with those lower numbers. It's when we get into these higher numbers, these types of problems, you'll start to see they're trying to count on in ones. They're trying to count backwards in ones. They're trying to keep track of this with their fingers. They don't have enough fingers for that. They're trying to keep track of it in their mind, and sometimes their short-term memory and their working memory is working overtime, and they're not going to be able to do that well. And then they start getting panicked and they get anxiety because they know other people are answering this faster than they are, and they're feeling like they failed. So that's why I bring up anxiety on this topic, because this is where you might really first see the signs of students who have anxiety with that. So the way I deal with this anxiety is I show them these problems and I show them, this is what I'm going to teach you how to do. So you don't have to count in ones and keep track of all these numbers in your head, counting backwards and forwards. Every problem here, I'm going to turn into a problem that has to deal with the number 10. We're going to teach you how to bridge through 10 or make the next 10. And I often will start with some of my middle school and high school students and say, what's easier for you to solve, 8 plus 7 or 10 plus 5? And they'll instant, well, of course, 10 plus 5, that's 15. I go, okay. What's easier to solve, 5 plus 8 or 10 plus 3? Obviously, 10 plus 3. What's easier to solve, 15 minus 8 or 10 minus 3? 10 minus 3 is easier, and so on. And then I say, well, guess what? 8 plus 7 is the same thing as 10 plus 5, and 15 minus 8 is the same thing as 10 plus 3. And I'm going to teach you with these dot patterns and 10 frames and number bonds, you're going to learn how to turn any problem into something you can chunk into tens, so it's a lot easier to see. So the skills and habits we're using to replace that math anxiety is the bridging through 10 or make the next 10 skill. And the habit is when they feel panicked, I have a little breathing method where you breathe into your parachute, breathe out a picture. So breathe in, breathe out, slow breathing. If they're in a full-on panic attack, obviously you're going to have to do some other redirection and visualization and calming. But if they're just getting in the habit of going, okay, I'm feeling panic, I'm going to breathe in. I feel like I'm in free fall. It's going to lift me. I'm going to build a model. And you give them lots of time to solve these problems. So here's what bridging through 10 looks like without Cuisenaire rods. My later example, I'm going to be using the Cuisenaire rods, but you can teach this method with Legos, with tens blocks, with Unifix cubes, with counters and buttons and 10 frames and number lines. So even though I'm going to be using Cuisenaire rods later, I just want you to know this method you can use with other, you don't have to buy new things if you don't have them. You can use what you have. So bridging through 10. So this is from my scripted lesson in the Dyscalculia solution. If you have this book, you can go to page 79. You'll find a fully scripted lesson going through Concrete-pictorial-abstract exercises for this. So you have 8 here and 5 here. You're going to have your student move 2 over. So now they have 10 and 3. So 8 plus 5 is the same thing as 10 and 3. It's 13. Singapore Math 1A textbook, there's going to be concrete examples and pictorial examples you can do with your student using, of course, the classic Singapore Math 10 frames. So here's an 8 made out of a 5 and 3. So 8 plus 5, you move 2 down there to make a 10. So now we see 8 plus 5 became 10 plus 3, became 13. And then with the workbook in Singapore Math for that same, the students are going to be taking their own pencil or pen and verbalizing as they make a group of 10. So here they see 8 ice cream cones. They're going to encircle, so it's kind of a pictorial concrete combo here. So now they have 8 plus 5. I bundle a 10 together. Now I have 10 and 3 more, so 8 plus 5 is 13. Okay, so now we're going to move to Cuisenaire rods. What are Cuisenaire rods? Yes, they are magic math sticks. I did not know what they were 5 years ago. I had no idea. I was like, how do people do math with these? Okay. And then I went down a fun rabbit hole. And the reason I'm not using just Unifix cubes or 10 blocks is because I kind of have a soft spot for these Cuisenaire rods because they were really the way my youngest son learned addition, subtraction, and times tables by using Ronnie Bird's books and ebooks. And he has dysgraphia and dyslexia and dyscalculia. So he didn't like to write a lot of stuff down. So all of these concrete, visual, and pictorial methods just really catapulted his math skills. So let's go in. Cuisenaire rods were invented by Georges Cuisenaire, a Belgian school teacher, schoolmaster, and a master musician. I think I did read somewhere that when he would teach music to kids, he's like, well, these kids can visualize, the pitch or the tone of the notes. I'm not a musician, so I'm probably saying this all wrong, but kids can visualize, how long or how high or how low a note is, a musical note. Why can't we do the same things with numbers? Why can't we give them a way to visualize kind of the quantity and the relative proportion of numbers to each other? So he made these rods. And they're still in use today. They were pretty popular in the 50s, 60s, and 70s. If you want to go down a rabbit hole, I recommend this video by Caleb Gattano in the early 1960s. It's showing first graders with Cuisenaire rods. Before he even teaches number names, he's getting them to do pretty advanced calculation and fractions with these Cuisenaire rods. So they're kind of fun. So I'm going to do a little example here with a student with math anxiety to show how we're going to model these problems and practice kind of breathing and making models and pictures and using that as our distraction and our new habit for anxiety. So one day Mila was out with her mom and grandma having lunch, and they walked by a clothing shop window. Mila saw a t-shirt she really liked and asked her mom if she could go in the store and see if she had enough money to buy it. They went into the store and Mila saw the price was $20. She looked in her wallet and saw that she had $7. Her grandma could see how much she wanted the shirt and told her she would pay for the rest and asked her how much more money she would need to buy the shirt. Mila was so excited and also panicked when she realized she had to figure out a math problem correctly to get the shirt. If she told her grandmother the wrong amount, it would be embarrassing when she went to pay for the shirt and the cashier said she did not have enough money. She felt so anxious just thinking about this happening that she could not focus her mind and be a calm and curious math model builder like she knew she needed to be to figure out how much more money she needed. Okay, so you might have a student say, well, why didn't the grandma just tell her how much she needed? Like my mom and dad would just tell me how much and figure that out for me. So we're going to have a teachable moment for neurodivergent awareness and neurodivergent affirming environment. Mila's grandmother had a hard time with math and spelling when she was in school. She's dyslexic, but never received help because very few people knew dyslexia existed when she was a child. Also, there were chauvinistic stereotypes that girls are not good at math anyway, so often only boys who struggled with math were noticed and given extra help. True story. Dyslexia, dyscalculia, ADHD, and autism affect girls and boys, and these stereotypes prevent students from getting the help they deserve. And I read in homeschool with my son in 7th grade, we read the Hidden Figures Young Readers Edition book. That was a wonderful book about Black American women in mathematics working for NASA during the time of segregation. And yes, the book is better than the movie. And the movie is not bad, but the book was wonderful. And my son started listening to a lot of podcasts about the Russian space program after reading that book. And then I say, I'm a woman and I got A's in math in school and I love math. And my favorite and the best math teachers I had were all women. My best chemistry teachers were all women too. And multisensory math has helped me become much better at mental math. And I wish I had been taught math the way I am now teaching you. It's the best way. It really is. Okay, so we'll go back to our problem. How did Mila find a way through this fear fog and solve the math problem? So when you're having anxiety attack or panic attack, it feels like you're in free fall. You need something to grab onto. You're going to fall. There's nothing to help you. it's panic, it's life or death in your mind, even though it's not really happening. So we want to say, take slow, deep breaths. Think about happy places, favorite places, do a little dance, get that panic out of your body, and then take some breaths, and we're going to solve this problem. So Mila remembered that in math tutoring, she practiced problems like this and did them correctly, but was finding it hard to remember how she did it. Right? When we're in panic, we cannot use our logic brain. We don't remember these skills. So we need to get calm, get our nervous system calmed down so we can learn. So she couldn't think clearly. That made her panic more. And then she remembered, breathe into my parachute, breathe out a picture. So you can practice some of this vagus nerve breathing with your students. So she's breathing in. The picture becomes a bridge to the solution. All right. And so always reminding your students to let you know if you have anxiety, always be observant. If you start noticing them getting distracted or shifting or getting nervous, talk to them about it, do a little redirection. Okay, let's practice breathing and talking like Mila did and see what happens. She's like, I have $7, but it costs 20. How much do I have to ask my grandma for? I'm going to breathe slowly and deeply in my parachute to calm my mind and slow that free fall feeling. So fill your parachute up slow so you can land on your bridge, which is your picture. And in her picture, she used Cuisenaire rods. Again, you can use number lines, you can use tens blocks, Unifix cubes, Legos, whatever you're using with your students. That's going to be their picture. Okay, I have 7 and I want 20. I know that 20 is always made out of 2 tens, so I can picture that in my mind. So this is 2 tens. She has 7. What does she need to fill in? 7 plus what is 20? She needs another 10 and a 3. So she needs 13. How much do I have to jump to get through 20? So another model with Cuisenaire rods, we could do it horizontally, like a number line, bridging through 10. You have 7. You're going to jump through 10, jump to the next 10 to get 20. That's going to cost you 3 and 10, so that's 13. And then on a number line, you start at 7, you need to get to 20. How much, question mark there, is that jump? How much is that jump? Well, before you get to 20, you get to 10, so you take 7 to 10, that's 3. From 10 to 20 is 10, so your total jump there was 13. And these are concrete and pictorial examples of CPA teaching methods. So you might have heard CRA or CPA, same thing, concrete representational abstract, concrete pictorial abstract. What does the abstract stage of this bridging method look like? Okay, so abstract is we're using these numerals, we're using digits. These are abstract symbols that represent real quantities. And that's why it's the abstract method. So 7 plus what is 20? Well, we know that 20 is always made out of 2 tens. So we want to turn that 7 into a 10 by adding 3 to it. And then so we have 1 10. We need another 10. So that mystery number there is 13, 3 and 10. If we solved it as a subtraction problem, what's 20 take away 7? We break our 20 into 2 tens. We take the 7 away from one of the tens. That gives us 10 plus 3 is 13. If it was an addition problem, 7 plus 13, we're going to break that 13 into a 3 and a 10 so that we can create another 10 and we get 20. Okay, I'm going to do 3 practice problems using the CPA methods. So we're going to do 8 plus 6. Then we're going to do a missing add-in problem, or also known as complementary addition for subtraction, and then a subtraction problem, 15 minus 7. So 8 plus 6, well, your student can model that concretely with the rods. A brown rod and a green rod is 8 plus 6. We can see that's going to be more than 10, but less than 20. Okay, to make that 8 into a 10, we're going to need 2 more. So we take 2 from the 6. That leaves 4 in the 6. And now we have 8. 8 becomes 10. 10 plus 4 is 14. So a problem that was 8 plus 6 becomes 10 plus 4. Okay, pictorial on a number line. Again, we have 8, and I'm going to put a ghost rod there just to model it. So we have 8. We need to jump 6, but now we're doing it on a number line. Where do we end up? Well, we had to pass through the 10. That took up 2 of our 6, but we need to jump a total of 6. So we need to jump 4 more. So we end up at 14. Abstract, 8 plus 6. We want to turn one of those numbers into a 10. Let's turn the 8 into a 10. So we take 2 from our 6. That becomes a 10. We have 4 left over, so that becomes 10 plus 4 is 14. Now let's do a missing add-in problem or complementary addition. 6 and what else will equal 13? So we have 6 and some other amount is going to equal 13. So that's my 10 and my 3. So that's our mystery amount there. Well, we could turn that 6 into a 10 by adding something to it. So we're going to add 4 to that 6. So now we have 10, but we need to get to 13. So we need to add 3 more. So now we have a 4 and a 3. 4 and a 3 is 7. So 6 plus 7 is 13. Pictorial on our number line. We have 6. We want to get to 13. How much do we have to add? We pass through our 10. That's going to take us 4. To get from 10 to 13, it's going to take us 3. 4 and 3 together is a jump of 7. So that mystery amount was 7. Abstract. 6 and what equals 13? And let's turn that 6 into a 10. So give it 4. So now we have a 10. To get to 13, we need 3 more. So 4 and 3 is 7. Okay, and here's a subtraction problem. 15 minus 7. Concrete, so build 15 with your Cuisenaire rods. We have a 10 and a 5. We want to take away 7. So it's essentially like crossing out 7 from that 10. And what's left after we take away that 7? Well, when we take 7 away from that 10, there's 3 left, and we still had that 5 from the 15. So the answer becomes 3 plus 5, which is 8. Pictorial, my 7, my 15. Jumping forwards or backwards, it's going to be the same amount. 15 minus 7, or 7 plus something equals 15. So if I jump forwards, 7 and 3 takes me to 10. To get to 15, I need 5 more, so the total jump was 8. Abstract, 15 minus 7. I can break that 15 into a 10 and a 5. Subtract the 7 from the 10, I'm left with 3 plus 5 is 8. That's subtracting from a 10. Let's do a different method. You can also do it this way, 15 minus 7. Let's turn that minus 7 into a minus 5 and a minus 2. The reason we split it that way is because we want to turn that 15 into a 10. So now we have 15 minus 5 is 10, and we minus the 2, and we have 8. And that's method 2, subtract from the 1s. And you can find Concrete-pictorial-abstract work for these in the Singapore Math 1A dimensions books. They'll have you practice both methods with your student. Okay, so after students have practiced abstract methods, concrete, pictorial, and abstract, and they've got these skills down, you want to use some silly online math games or silly math games instead of just worksheets for review and practice. The games add little breaks, give a little dopamine between each problem, and you're just going to have your students verbalize out loud, like, how are you making that one a 10? Which number gets to become a 10? How are you doing that? So let me show you a few of these games.